Good morning, folks. Ben, you out there? I see Ben in the chat, but I think we'll wait for him. Siggy, are you out there?
Yes, I'm here.
Okay, good morning.
Morning.
Once Ben checks in here, we'll get the screen share shifted over to you.
Sounds good.
We'll start in just a minute, folks. All right, let's get started, folks. Can everyone hear me? Can people hear me?
Yep, you're good.
Awesome, excellent. Okay, so the first thing I wanted to do to kick things off, so today we basically have Sugu to present on Vitess, and I don't know if he's on.
Yep, he's on. He's ready. We just need to pass him the ball whenever you're done.
Perfect. So just before we do that, I wanted to address last week's face-to-face. And in particular, some of you might have been there, some of you might not have been there. But I wanted to reiterate to this group, and I'll probably do this the next couple of these meetings as well. I just wanted to reiterate the CNCF's Code of Conduct, which I just pasted in the Slack channel. And in particular, I wanted to reiterate that while I think a lot of us are very passionate about each of the work that we're doing and how we want this all to play out for
סגור גם שם, חכו רגע.
Can folks that are not talking mute? Thanks. Okay. I wanted to reiterate that the expectations that we have around collaboration, around discussion, around professionalism, around not personally attacking people, around using the right tone and being generally pleasant and enjoyable to have be part of these calls and be chatting and working with everyone. If I'm not seeing that, I'm gonna pull you aside and ask that we have a discussion and potentially ask that you leave the working group. So with that said, any questions that folks have? No? Okay. Okay, so we have Sugu here to present on Vitess, and I just shared another link in the Slack channel, which is his presentation. And I think we can pass the ball to him and he can get going.
Cool. Hi there. Let me share my screen. Okay. Can you see my screen?
That's good.
Cool. All right. So my name is Sugu, and I've been at YouTube for about 11 years now. And I've worked on various scalability and infrastructure projects. And my last project has been Vitess, which I'm going to talk about. So this presentation, I kind of put it together to address many of the questions that CNCF has for due diligence. It didn't feel like it flows well, but it should cover all the information that you need. So hopefully it won't be too rough. So Vitess, our mission statement has been to be the best performing and scalable MySQL solution in the cloud. Actually, our real mission statement is to be a NewSQL storage solution, but there are a few items that we are missing that we'll get to as we address issues. Before I jump into what Vitess is, I wanted to cover quickly MySQL because not many people are familiar with its significance. So MySQL is basically an RDBMS. So people usually choose an RDBMS over a traditional NoSQL system. Like MongoDB is usually because they want secondary indexes, joins, or transactions, which basically make the application simpler to write. Without these, application has to take on these burdens. And MySQL itself is by DB-Engine's ranking is the second most popular storage engine in the world. So it still has a huge, pretty huge following. One of the main disadvantages of MySQL is that it's a single instance server. Once you've maxed out your machine, you're pretty much done for in terms of scaling. You cannot really scale beyond that. But you can scale reads by just adding more replicas. So that support is still there. It's actually not a big data server by itself because it's usually awesome for something about from 100 GB to 1 terabyte size per server. Beyond that, if you start adding, if your database gets bigger than that, then you start to run into various issues with MySQL. And in terms of cloud support, there's only these hosted solutions like RDS and Cloud SQL. MySQL itself doesn't have much help in terms of if I want to just take stock MySQL and run it in the cloud, there's not much help. And Vitess actually is trying to help solve that problem. So what is Vitess? It basically solves three problems for MySQL. It helps you manage a large number of MySQL instances when the as you scale, when the number of instances gets really, really big, there is not much help from MySQL about managing them. So Vitess helps you with that. If you actually are on bare metal and want to move to the cloud, you can use Vitess to move your MySQL instance to the cloud. And the last but not the least is that it's actually gives you NewSQL style scalability. When your database runs out of steam, you can just shard and continue to scale. So those are the three main features that Vitess gives you. In terms of categorization, so prior to this whole NewSQL wave that's coming up, people had to choose between either an RDBMS or a NoSQL. So basically you either choose scalability or you choose data integrity features, but you can't have both. And that has been a problem because many of the complex applications do want both. So hopefully the NewSQL wave will solve that problem. So there are actually many NewSQL systems. There's now TIDB. There's also Citus. I need to actually update the slide. Some people actually were questioning whether Vitess is or should be a NewSQL system. And there are many definitions. It's still gelling. So what I've done is I've put Vitess slightly below the bar, saying that we are almost there, but not quite there yet. But it does play in that space. Most people that want to scale indefinitely an RDBMS style system tend to converge to Vitess. In terms of history, this project is pretty old. We started actually in 2010. This was a time when YouTube was actually having some severe scalability problems. Actually, the number of outages were growing and they're pretty much getting out of control. So myself and my colleague, Mike Solomon, we took ourselves out of the day-to-day operations and decided to see if we can come up with something that will let us leap ahead of all these problems. So that is basically how Vitess was born. But what we realized was that the problems we are solving are actually common to many organizations. So we decided to actually open source it. So initially, even though we open sourced it, we mostly used it for ourselves, actually. We used to develop in the open source world and import the data and use it for ourselves. Nobody else actually was participating. But over time, the number of features we added kind of became comprehensive. And Flipkart was also facing scalability issues, and they somehow found us and contacted us and said, hey, do you think we can use this? We said, sure, give it a try. We'll help you to the extent we can. And then a year later, they went into production, which was pretty exciting. And then after that, that credibility attracted more users, and it has been pretty much growing organically since then. So we haven't been actually, there's not much hype around Vitess, so most of the Vitess growth has been very quiet and secret almost. But it is it's grown pretty fast now. We now have like a Slack channel that has about 200 members. And so if you look at our community, so these are the companies that are currently using or adopting Vitess. The group that you see on the left are actually people that are already in production. And the group you see on the right are people that are either in the pipeline or evaluating. Actually, there are more companies than this. We only have permission to use these logos, which is why I've used them. There are other companies that have actually, some of them are actually quite big that have gone into production, but they haven't given us permission to use them as a reference yet. So it's pretty exciting, this part. And so there are some testimonials, but both from Slack and Square that I collected because people wanted to hear from them about whether how they support CNCF. You can actually see the full text. I've linked the document. These are just some excerpts. So what are the things that Vitess does for you? In the area of making MySQL better, it allows you to run MySQL in multiple data centers, takes care of failovers, load balancing, and one problem that MySQL has is it cannot handle a large number of connections, or if there's a huge spike in requests, it just falls apart. So Vitess actually protects MySQL by using connection pools that limit and throttle the traffic. And often, sometimes expensive queries hit MySQL and take the entire database down. So MySQL is something that cannot, where one query can actually affect everything else. So when these things happen, Vitess intervenes and kills queries that are taking too long or transactions that are lingering. So actually, we have been developing these features at YouTube, basically based on issues that we have been seeing in production. And these are actually things that anybody that's using MySQL will relate to, because these are problems that all of these people face. And it is now so well tuned that people that go into production with Vitess find that their MySQL generally runs better than it used to run before. Actually, these are actually not cloud features per se, but the entire Vitess software is written for the cloud. So there's actually subtle cloud-related behaviors in all of these features. So that's actually my next slide. So Vitess. The way actually we wrote it is Vitess was built to run in Borg. So what we used to do is, even though we built it in the open source, we had to actually import it and actually adopt it to run in Google's Borg cloud. So we had to use log servers, discovery mechanism, health check, everything that Google required for software to run in its cloud. We had to do it for Vitess. So in a way, we were actually cloud ready before even Kubernetes was born. So when Kubernetes came about, it was actually very trivial to make it work under there because all the plugins were in place. Actually, running in a cloud is not just checking these boxes, because there is a specific way you have to think about software. Like, for example, you cannot rely on config files and expect them to be sprayed around to change the way software behaves. You have to use the log server mechanism to publish changes. You have to rely on basically the file system is not something that you always have access to. You cannot log into a box and look at what's going on all the time. And also when you use a log server, you have to be careful about not overloading it, because it's not something that you can afford to spam. Those are actually low QPS systems that you shouldn't abuse. So all these things, we actually learned them the hard way and actually changed Vitess to actually treat these external systems correctly so that it works well. So the best feature for Vitess is definitely the sharding. That's the one that attracts most users. Basically, once you outgrow one single instance, what Vitess lets you do is actually shard your database and continue scaling indefinitely. So the way it does it is basically it lets you view the sharded database as if it was a single instance. So when you send a query, it figures out where and how it should route that query, or split it into parts and send it to different parts and then collect the results. And there's database-like features in this sharding. We have cross-shard indexes. MySQL users rely a lot on auto-increment, and we have sequences that behave just like those. But then it works for cross-shard sharded databases. The other one is actually the pluggable sharding scheme. This is actually something that MySQL users prefer. I think it's something that most users should prefer because I don't think systems are there yet where they can be good at figuring out how to shard your data. So if the system made a decision about how data should be sharded, it is most likely not going to be the most optimal one. Hopefully machine learning will help us solve this problem. But for now, this decision is best made by a human. So therefore, we not only make you decide how you want to shard your data, you also decide the sharding scheme that you want to use, which is something that many MySQL users want. Because not everybody likes a hash-based sharding scheme. Somebody wants to use mod-based, somebody wants to use an MD5, or somebody just wants a sequence. So that's one thing that Vitess is very good at. The most important thing is that the sharding scheme and the cross-shard index feature actually work hand in hand together. You can even reshard your database after you've plugged in your sharding scheme. And when you reshard a database, Vitess can do it with almost no downtime. The application will almost not know what's going on. There's probably about like a few seconds of downtime when you switch over the masters, which actually the proxies will just buffer those requests and the application will see almost no downtime. And finally, because you're sharded, you're probably going to have transactions that span across shards. So for that, Vitess has support for 2PC transactions. There are limitations. These are actually all addressable limitations, but we just haven't prioritized them yet. The one thing is 2PC is actually a new feature that we developed. It's the first version and it is expensive. And but then somebody that really wants it can have it, but they have to pay the price. It essentially results in about 50% increase in data throughput requirements. So it does reduce your serving capacity. But then if you can shard, you can just go wider. The other one actually is the big one, which is when you do cross-shard reads, Vitess doesn't give you a consistent view of cross-shard reads. So that's one big limitation that Vitess has. We have some proposals about how to address it. But actually, none of our users have really asked for it. They don't seem to think it's so important. So it may be we haven't encountered users that need this yet. So, but this is something that is in our radar. When you issue a SQL and if all of that SQL can be served by one shard, then Vitess is very good at figuring it out and sends that entire SQL to one shard. But if your SQL spans across multiple shards where you have to do cross-shard joins and stuff, there is some amount of complexity that it can handle. But if the query is too complex, it will say, sorry, I can't do this yet. So this is also something that we plan to address in the near future. The enterprise style users, the one thing that their main complaint has been that it's very complex. It's basically because we have been growing it for 7 years. It has a lot of options, and sometimes people get confused about what works with what. And so right now they do need to talk to us sometimes too when they have trouble configuring Vitess. So this is another big area that we have to focus. Actually, these last two currently are our biggest priority. The documentation and reducing the complexity of bringing up a Vitess cluster. But the good news is that once you have configured Vitess, it runs really smoothly. So that's been the experience with our users. All right, so this is actually the Vitess architecture. It shows how we do what we do. The way Vitess is configured is that every MySQL instance, we attach what we call as a VT tablet, which is actually all queries go through VT tablet. And VT tablet makes sure that the queries don't abuse MySQL. There are lots of protection. Like for example, if two identical queries hit MySQL, it won't send them both to it. It will send only one of them and then share the results to everybody that has requested it. And VT tablet also can perform housekeeping work like taking backups, restores, and all the cluster management work it can take care of. On this side, on the proxy level, there is this thing called VTGate, which is actually stateless. So it's something that can scale up and down as needed when the load on the application goes up and down. And the application knows only about VTGates. It does not know about all the details underneath. So it'll just send the query as if VTGate is one big giant database, and then VTGate will figure out how to get that query served. So it greatly simplifies the view the application has about the cluster underneath. And how do we tie all this together is actually through a log server. Here I have put etcd, but actually Vitess supports all the log servers. It keeps track of which tablets are going up and down and informs VTGate of those changes, and then VTGate accordingly routes traffic. And VTC-TLD is our dashboard that we use to look at what's all the cluster and perform actually operations like reparenting, resharding, etc.
Hey, Sugu, are you taking questions now, or do you want to save them till the end?
I can take questions now if it's immediately relevant.
Could you talk a little about what information is in etcd?
Yes. So etcd, there's actually it's actually a lot. It's pretty elaborate. We actually you can actually use multiple log servers. We have one called the global log server, which is actually unique across all data centers, and we actually let you configure one log server per data center. So the idea is that when one data center goes down, it does not take everything else with it. And the global log server has very little information. It only tells you where the master database is. It tells you how your database is sharded, what key spaces you have, and how your database is sharded, and nothing else. But the individual log server, the data center log servers contain information about each VT tablet, where are the replicas, and if something is down for backup, it updates those states.
So the information about the shards and where they are is all in etcd?
Correct, yes.
And does the VT tablet require access to etcd?
Yes, it does. A VT tablet actually will, when it comes up, it will actually register itself with etcd saying that I am now here, and I'm now a replica, and I'm ready to serve traffic. And that will eventually, and VT gates are actually have a watch set on this etcd. So when it comes up, they'll receive the notification, and we'll start sending, we'll start load balance, including that VT tablet in the load balance.
Great. And you talked a little about connection pooling and all sorts of client features as well. Does a normal MySQL client, say from a PHP or Python or Go, work with Vitess, or do you have a different client?
No, actually, we recently implemented the MySQL protocol at the VTGate level. So a PHP client could just connect to VTGate as if it was a MySQL database.
And it's transparent? There's no difference?
Yeah, yeah. So there are actually some differences by the fact that things are sharded, and the fact that, for example, the VTGate here represents all the databases here, like master, replica, and stuff. So the app server could, for example, say, I want to connect to my key space, but I want to connect to the master. So we have an extended syntax where it says, I want to connect to key space at master.
Great.
So there's some extensions, but otherwise, query-wise, it's the same. You just send, once you've specified your database, you just send queries like normal. And we also have some non-standard extensions. Like, for example, you could issue show statements that return information about shards. Like, for example, you can say, show me all the key spaces here, or show me all the shards inside the key space. So a few extensions which people can optionally use. But typically, if you just point your app to VTGate, it should work as is.
Great. Thank you so much.
And we also actually have a gRPC API at the VTGate level. And we have, right now, we only support Java. The gRPC actually gives you a few advantages over native MySQL. It lets you use bind variables at the app player itself, which makes things a little more efficient. And not only that, it actually makes these VTGates truly stateless, which means that you could start a transaction with one VTGate. And if that VTGate goes down in the middle, you can actually complete that transaction using another one. So it's truly stateless and load balanced. So that's, but we have noticed that most people don't care much about this feature. So most of them just use the MySQL protocol. All right. So this, the whole idea of this thing is we actually worked very hard at reducing the number of moving parts here. These are things that we felt are absolutely necessary anything less would be a problem or anything more would be a problem. So this lot of thought has gone into this architecture, and this has also been tuned over many years. So I think we are very happy with what we have here, and we are probably going to stay with it for a very long time. In terms of versatility, this is where Vitess really shines. It can pretty much run any place, anywhere. Right now, it runs like YouTube runs Vitess on Borg. Stitch Labs runs it on GKE. Better Cloud uses Mesos and GCE. HubSpot uses AWS and Kubernetes, and others like Booking and Flipkart, they basically run on bare metal. There's actually a bunch of users that run on bare metal. It can also work with any log server. When we import Vitess, we basically swap in Chubby. We originally developed it with Zookeeper, but now we also support etcd and Consul. And all these are used in production by someone or the other. And in the same way, in the open source, we use gRPC, but when we import it, we swap it out for Stubby. And there are plugins that people have provided for monitoring with Prometheus, InfluxDB, this CollectD, and obviously Borgmon internally. So this is actually the stuff that we spent a lot of time in our software design. Vitess is truly pluggable. So basically, it's not just these things that are pluggable. There's actually a whole bunch of things that we do when we import Vitess into Google. We add throttlers, we add monitoring, health checks, ACLs, Dapper, and actually the list is pretty big. These are some of the big things that I wanted to mention. And the most importantly, this pluggability does not affect efficiency. Typically, if you deploy Vitess on top of MySQL, what people have reported is about under 2 millisecond overhead added to what would have otherwise been a direct round trip with MySQL, which most of them find acceptable. And over time, we have actually, when we started, we were not very disciplined, but then we brought in some discipline about coding. So our coding standards are pretty high and stringent. Readability is the most important thing when somebody writes software. We spend a lot of time making sure that it's structured such a way that anybody else that comes in and reads the code can understand what's going on. And this has actually attracted more contributors, and they've all been very happy with Vitess's code. We follow all Go coding standards. We require unit tests to be written with strict coverage requirements. If needed, end-to-end tests have to be written, and they should not affect performance. And we integrate with Travis, CodeClimate, and Netlify, which runs all the unit tests, all the tests, unit tests and end-to-end tests before we actually merge code in. So this is because our master branch is something that we import from regularly and deploy on YouTube. And many of our users do the same thing. So we require the master branch to be absolutely stable all the time. There are only 1 or 2 users that use an official release of Vitess, which is currently at 2.1, and we are about to release 3.0. In terms of, I looked at the contributions, the big ones came from YouTube, Slack, and HubSpot. GitHub and Booking actually came on board later this year, and they are beginning to ramp up their contributions. And Square has also been contributing. And finally, these are the stats that we have for Vitess overall. And the big one is that the Slack is growing. The one downside of Slack is that you don't realize how much activity is going on there because it's a private channel and it's not Google searchable, but there's a lot of activity going on there. Yeah. So this is pretty much all that I had to cover. Let me know if you have any questions now.
Hey, Sigurd, thank you for the presentation. I think that something that the TOC is going to ask, just to play devil's advocate with you, and something to prepare for is, what do you like? why do you want the test to go to the foundation? Like, what do you see as the trajectory for the test if it's accepted as a project?
Yeah, actually, the main thing that we are looking for, actually, this is the reason why YouTube is pushing, is very insistent on this happening, is that Vitess is being seen as a project owned by YouTube. And we want to change this to be a project that is owned by the community, by the fact that all these people depend on it and they contribute. So somehow we want to change that impression. That by far is the biggest factor. But like, it doesn't hurt that we haven't actually, Vitess is, the other thing is we hope that CNCF will increase visibility of Vitess overall. So far, it has only grown through word of mouth, and that is the other big thing that we expect from CNCF.
Is the like the YouTube participation in the project? Are you expecting it to increase or decrease? Like, what are the plans for YouTube with Vitess?
So it will. So basically, YouTube is committed to. So the way Vitess has grown is the features that YouTube uses. Actually, I don't know if you have heard. YouTube has made a decision to actually migrate to Spanner, but it's a multi-year project. But then YouTube is still committed to supporting Vitess, and therefore it wants to make sure that it grows the community and establishes leadership. It doesn't know how long it will stay involved with the project, but it's possible that maybe a year or 2 years from now, it may not be as involved as it is right now.
So can you talk a little bit about the kind of differences between Vitess and Spanner?
Yeah. So architecturally, they are very different because Vitess relies on an RDB, on a relational database underneath. So because of that, that makes it a very different product compared to Spanner. However, we do get we do get compared with Spanner, Cockroach, TIDB, all these NewSQL databases. The way I would compare it is usually Vitess is better at handling SQL as a language, mainly because it relies on a real RDBMS underneath. So in that respect, for example, it supports DMLs, which allows you to change data using SQL statements, which systems like Spanner and CockroachDB don't support. The place where it falls short of Spanner is something that I mentioned in the limitations, is that Spanner uses an LSM system, and it can actually obtain a consistent cross-chart view of the data, which Vitess cannot do right now, because for that you need to actually, the underlying database has to support that feature, which MySQL doesn't support yet.
Yep.
But otherwise, if you are just coming top-down, for you, there is very heavy feature parity between Spanner and Vitess. They both scale equally well. There are some differences in how we like, for example, Spanner has quorums and they have cross data center quorums. So they give you better durability for your transactions, but then you also pay the price in terms of latency for it. Whereas Vitess relies on a different mechanism called semi-sync replication, which relies on within data center quorum style consistency, which is actually faster.
Have you, just another quick question, have you considered at all supporting PostgreSQL as well as MySQL?
Oh, yes. It keeps coming all the time, because if you look at the architecture, nothing prevents us from actually replacing this pair with a Postgres, with a VT tablet that can handle Postgres. Yes, that is definitely something that is on our radar. But the thing though is right now we have our hands full supporting the MySQL community.
Yeah.
So once that pressure goes down, like every week we have a new user that come up and says, "Oh, I need help here" and stuff. So it's been pretty busy lately, just supporting what we have now.
Do you feel like the work that you've done in terms of VTGate and rewriting queries and sharding and all that stuff is equally applicable to Postgres?
Oh yes, totally.
Okay.
Because if you actually looked at the VTGate code, all it does is look at SQL by the SQL standards and figures out how that SQL needs to be broken out into smaller parts and sent to different instances underneath. So if you actually, what you would need to write is actually a new VT tablet component for Postgres that can manage Postgres here on this side. So once you have that, from the VTGate perspective, it is just routing the query.
That's great. Thank you.
Hey, Sugu, it's Alex Kirkup. Got a question. How is Vitess actually deployed, and how do you see that sort of integrating with, say, an orchestrator?
Oh, that's a very good question. You mean the orchestrator by Shlomi?
No, the orchestrator is in. So how are the various moving parts of Vitess, however small they are, what deploys them, and how are sort of clusters scaled or sized?
Oh, okay. So actually, we where is this? I'm looking for the slide here. So we actually have Helm charts and Docker Compose as an example. So this is one place where we could probably do more work, deploy more examples about how to make Vitess work in a Kubernetes instance. We currently have a few examples in Vitess to talk about how actually Anthony Ye gave a demo once. He just went there, he took the Helm chart and he issued one command and he brought up the entire cluster, which was pretty exciting. But people that have gone into production, HubSpot actually uses Kubernetes in AWS and EC2. They said that both the HubSpot and Stitch Labs also Stitch Labs uses GKE. They said that they did have to create a few scripts to deploy Vitess. So that part is something that we can definitely do more work on. So within YouTube, actually, it's a pretty big instance. I think we have like tens of thousands of nodes and pretty high QPS as a setup, like about 20 data centers or so.
So Sugu, is it safe to say that there's not like a controller that's been built for Vitess for Kubernetes? Or is the Helm chart deploying a controller that then handles the scaling? How does that actually work?
So right now, the way I think they've done it is, so when you scale, you actually, so once you have the Vitess setup done, you basically, there are, as you can see, there are very few moving parts here per se. So scaling Vitess basically involves just bringing up more and more replicas here. And those you can just...
That's an operation that a human does today?
Correct, yeah. Yeah, okay. So the reason is because, so VTGate is actually auto scale. That scales up and down automatically based on the load generated by the app. But here they actually have to provision because they have to decide how much disk they want and stuff. So you're right, this is one place we could probably support auto scaling, but we don't do that right now. So a human has to say, oh, looks like our read traffic has gone up. We need to bring in, add more instances on this side.
And kind of following up where Clinton, I think, was going, is this something that could be completely transparent if you had an autoscaler for the shards? From the app perspective, does it look completely transparent?
Yeah, I think so. Although that scares me a bit because because we don't know whether an increase in load is due to a legitimate increase in requirement in the load, or whether there's an abuse going on.
Okay.
I would be slightly hesitant to make this auto scale. Nobody in YouTube has ever asked to auto scale these things. The SREs actually want a complete control over how many instances. These are actually planned on a weekly meeting where we say, oh, looks like we need to do reshard, looks like we need to add more replicas. So these are humans, at least in YouTube, humans have preferred to make these decisions.
Great. And I assume you have support for collapsing shards, right? Recombining them?
Yes, we support both splitting and merging.
Great.
And then one other question about the VT tablet configuration. So once you've got sort of obviously a very tightly coupled relationship between the VT tablet and an instance of MySQL, does the VT tablet handle any of the functionality in terms of actually managing the life cycle of that MySQL instance, i.e. keeping the service alive or maybe upgrades of the software or any of those sort of things?
Yeah, that is actually VT Tablet's job. Right now, it actually, the main housekeeping work that it does is actually taking backups and performing restores. It also helps you with the schema deployment. And then there is also coordinating about who is the current master. So those are the housekeeping work that VT Tablet does for MySQL. Other than that, all it does is serve queries. Okay.
And the coordination of who's the master, does that happen in concert with etcd, I assume?
Yes. So we actually have, you can actually issue manual failovers or reparents. And then, so the one thing though is here is that when a master failover happens, it's actually, you have to actually inform the VT gates immediately. You cannot afford to go through etcd because that is actually generally the SLA for something like etcd disseminating information is usually 15 to 30 seconds, and sometimes even longer. So the way we do this is actually these VT gates are connected to these VT tablets, and there is actually a health check stream that flows from all the VT tablets to VT gate. So as soon as a VT tablet becomes a master, the health check immediately informs the VT gates, and within seconds, all VT gates have moved the traffic over to the new master. So etcd is mainly used as passive discovery.
What about the configuration of MySQL-D? Obviously, it's got a ton of config, and a lot of it is very, very sensitive to performance. And is that something that you could specify centrally with Vitess, or is it something that you still have to manage through the MySQL conf and other stuff?
So Vitess actually has a tool called MySQL CTL, stands for MySQL Control, where we have simplified how you configure MySQL. And actually, a lot more people than we expected use it, because we thought that most DBAs like to configure their own MySQLs. But a large number of people actually have adopted that tool. It actually makes it very easy to spin up MySQL instances. And the good thing that MySQL CTL does, the way Vitess works is like we run small instances of MySQL. So in a particular box, you could probably see 20 or 30 instances of MySQL running per box. And what MySQL CTL can do is actually isolate all of them. The default MySQL is expected to be running like one instance per box. But then we have changed it such that it configures it to make sure that they are each isolated from each other. So people actually try to use MySQL CTL to a large extent, and many of them do.
Okay. And do you allow shards to be of different weights? You know, big machines, small machines, etc.
Right. Yeah. You can actually decide your shard. So basically, you can decide the size of your shards by the final low-level sharding unit is actually what we call a key space ID, and the ranges can be non-uniform.
Oh, great.
And that actually, StitchLabs especially uses that because they are a multi-tenant system where some retailers are huge and some retailers are small. So like for the big retailers, for example, they have just a shard dedicated just for that retailer.
Great. Thank you.
Hey, Sigurd, if you were going to compare this, or if someone was making a decision to leverage, like in the public cloud, if they're going to leverage Amazon's RDS or Google's SQL Cloud, like what would the decision, like what kinds of things do they consider when they decide to either use Vitess or the public cloud SQL instances?
So actually, Vitess can make both RDS and Cloud SQL better because, I was talking to somebody from Amazon. They said that Vitess can even help with Aurora. It's because Vitess can do sharding and none of these systems can. So if you deploy Vitess in front of RDS or Cloud SQL or Aurora, you solve the big scalability problem that they have where the write throughput is limited by the fact that only so much can be handled by one box.
So how does that look like? Doesn't VT Tablet require a Unix socket to MySQL? How would that work with RDS?
No, actually, this is how we presented it here, but VT Tablet can run outside of the box that MySQL runs on. It can just connect through a regular port.
I see.
And actually, Square uses it that way. They actually have a huge MySQL instance. They are coming from a monolith MySQL and they're slowly sharding out of it. And they cannot afford, they actually, the way they are set up is the MySQL is administered by a different team. So they actually run Vitess as if it's an app. So it's actually VT Tablet runs in a separate box and drives MySQL. So in the case of RDS, that's exactly how we would run it. We'll just have VT Tablet outside MySQL and just connect through a TCP port.
So I'm definitely not an expert with RDS or Google's Cloud SQL, but you're basically saying that there's limited scale in those services, and Vitess is going to allow you to have a wider scale.
Correct. Yeah. So RDS, Cloud SQL, or Aurora, their limitation is each instance is only one machine. So you can choose the size of your machine, but once you've gone to the largest machine that you can get, that's pretty much you are pretty much stuck there at that point. And if your data size blows up out of control beyond that, then you're in trouble. And we want to do actually RDS. Fortunately or unfortunately, nobody has asked for it yet. But and we've been busy supporting the current community. But if the next person that comes on board says, "I want Vitess for RDS," we'll probably focus our energies there at that time. So we think it's actually very little work. It's just that we haven't spent the time.
Okay, thank you.
Sugu, what is the largest deployment of Vitess? Is it still MySQL? I'm sorry, YouTube?
Actually, I won't be, the largest instance would probably be YouTube. But based on some of the numbers that people have reported at this point, I won't be surprised if what is outside YouTube combined is bigger than YouTube inside. Some of these guys are pretty big in what they have. Slack is in the hundreds of thousands of QPS. Same with StitchLabs. Mm-hmm. And some people who have not mentioned, one of them said that they have like 300 databases, and some of them sharded that they are fully into production. So I don't have an exact estimate, but approximately what is currently outside YouTube now is definitely set to exceed what YouTube has internally.
And have you had any discussions with the folks over at Facebook around sharding and MySQL? I know they do a lot with this stuff as well.
Yes, I do talk to them every time. Every time I go to the conferences, I talk to Mark Callahan, who is their architect for MySQL. Every time they mention that there are places where they can use Vitess. Actually, I met the head of their SRE last week, and he was still saying the same thing. But I think there's also the fact that things are working now at Facebook, and there is inertia about taking the effort to replace what's currently working with something else. So I think eventually, I think the way they would, both Facebook and other companies are also going through this, is when they encounter big problems, when they say, okay, we need something to be changed at this point, is the time when they would do it. But there's like no motivation for someone to change something that's currently working and fine.
Thank you.
I've got one more. I know we only have a few minutes, so is there anyone else out there that has a question for Sugu? All right, one more. So regarding the interaction with MySQL, has anyone who's a contributor to MySQL expressed interest in absorbing some of the features of Vitess? Because you described the BT tablet, and it seems like some of that throttling or other logic that's in place there, it could be beneficial to MySQL on its own. Any discussions there for what pieces make sense to stay in Vitess and what pieces may just need to be absorbed into MySQL?
Yeah, I don't. I talk to the Oracle MySQL team at least twice a year, and for one reason or another, none of them think that it's important. I don't know why, but I think they are still. So there is some relational trade-off that we make when we do a connection pool, for example, right? Like at that point, each individual connection is actually stateless, which is actually not, which is actually a move away from a relational concept. So I have a feeling they don't want to go that route. They want to remain a pure relational database that honors everything. Because if you, for example, if you connect to MySQL, on that connection, for example, you can create session variables, there is state, all those things actually make every connection unique and expensive. But because of the fact that they are committed to supporting those features, they cannot move into something that what Vitess does. In Vitess's case, what we say, those are actually features that most people don't use. In Vitess, all we say is, well, we don't support those features, so don't use them. And most people are happy with that. So yeah, and if you ask me, they should be part of MySQL. And the only reason we actually tried to change MySQL to push some of these features inside there. But what we realized was that as soon as you patch MySQL, nobody wants to touch it. Because it's very hard to build it. It's people have trouble downloading, building. So we started with a 5-line patch, and nobody wanted to use it. So we quickly moved away from that and made a decision that we will work only with stock MySQL as is.
Great, thank you. Hey Ben, are you out there?
Yep, great. So thank you so much for the presentation, Sugu, and let's wrap it up, and
thank you.
We'll probably see everybody in the new year. Thanks, folks.
All right, thanks so much. Thanks again.
Thank you.
Have a great holidays.
Thanks. Happy holidays.